What if I told you that every atom in your body was forged in the heart of a dying star? But that's not even the most mind-blowing part. Here's what will absolutely shatter your understanding of reality. The galaxy you're sitting in right now. The Milky Way is currently cannibalizing another galaxy as we speak. In fact, it's been eating the Sagittarius dwarf galaxy for the past 4 billion years, ripping it apart star by star, and you never even noticed. But that's just the beginning. What I'm about to show you in the next 1 hour will completely transform how you see the night sky, how you understand your place in the cosmos, and most importantly, how galaxies, these massive island universes containing hundreds of billions of stars, actually come into existence. Most people think galaxies just appeared, fully formed cosmic cities floating in space. But the truth is far more violent, far more beautiful, and far more connected to your daily life than you could possibly imagine. By the end of this journey, you'll understand why the coffee you're drinking right now exists because of galactic collisions that happened 10 billion years ago. Before we dive into this cosmic odyssey, hit that like button if you're ready to have your mind completely blown. Subscribe if you want to join our cosmic community, exploring the deepest mysteries of the universe. And tell me in the comments, what country are you watching from? And what time is it where you are? I love seeing our global family of cosmic explorers come together. Now, let me ask you something that's going to haunt you for the rest of this video. If galaxies are born, grow, and eventually die, what happens to us when our galaxy's time is up? Let's start with what you think you know about galaxies and prepare to have it completely turned upside down. Think of it like this. Imagine you're looking at a bustling city from an airplane at night. You see the lights, the organized patterns, the clear boundaries. That's how most people imagine galaxies. Neat, organized, stable structures floating peacefully in space. But here's the first mind-blown moment. Galaxies are actually more like massive storms that last for billions of years, constantly growing, constantly changing, constantly consuming everything in their path. The Milky Way galaxy, our cosmic home, contains somewhere between 200 to 400 billion stars. That number is so large that if you counted one star every second, it would take you over 13,000 years just to count them all. But here's what will blow your mind. Despite containing hundreds of billions of stars, galaxies are mostly empty space. If our solar system were the size of a quarter, the nearest star would be about 500 miles away. Now, here's where it gets weird. Galaxies don't just sit there looking pretty. They're incredibly active, dynamic systems that are constantly being born, constantly growing, and constantly interacting with each other in ways that would make the most dramatic soap opera look boring. But before we dive into how these cosmic monsters are actually born, I need to destroy another assumption you probably have. You likely think that galaxies formed after the Big Bang, right? Stars first, then galaxies. Makes sense. Except it's completely backwards. Here's the shocking truth. Galaxies actually helped create the very first stars, not the other way around. Think of it like this. Imagine trying to build a house without a foundation, without materials, without tools. That's what the early universe was like. Just a thin soup of hydrogen and helium atoms floating in the darkness. No stars, no light, no structure. So how did we go from this cosmic emptiness to the incredible galactic structures we see today? The answer involves one of the most mysterious and powerful forces in the universe. Something that makes up 85% of all matter, but is completely invisible. We call it dark matter, and without it, you wouldn't exist. Neither would Earth, the Sun, or any galaxy in the universe. Here's your second mind-blown moment. The visible matter, all the stars, planets, and gas clouds you can see in photos of galaxies, is just the tip of the iceberg. Every galaxy is actually embedded in a massive invisible scaffold of dark matter that extends far beyond what you can see. These dark matter halos are like invisible cosmic cities, and the beautiful spiral galaxies in those stunning Hubble photos are just the lights decorating the buildings. But this raises a terrifying question that we'll answer later. If dark matter is so crucial for galaxy formation, and we don't really understand what it is, what happens if it's not as stable as we think? Here's what will blow your mind. Before there were any stars, before there were any planets, before there was any light in the universe at all, invisible dark matter was already building the cosmic architecture that would eventually become every galaxy you see today. Let me paint you a picture of the early universe that will completely change how you think about cosmic history. About 380,000 years after the Big Bang, which sounds like a long time, but is actually just an eye blink in cosmic terms. The universe was a dark, formless void filled with hydrogen and helium gas at a temperature of about 3,000 degrees Kelvin. No stars had formed yet. No galaxies existed. But something incredible was already happening. Dark matter particles, which don't interact with light or normal matter except through gravity, had already begun to clump together under their own gravitational pull. Think of it like this. Imagine you're at a crowded concert, and suddenly everyone starts moving towards certain spots in the crowd. These spots become more and more crowded until they form dense clusters of people. That's exactly what dark matter was doing on a cosmic scale. Dr. Vera Rubin, one of the most important astronomers of the 20th century, discovered this invisible scaffolding in the 1970s when she was studying the rotation curves of spiral galaxies. She expected to see the outer stars moving slower than the inner stars, just like how planets farther from the sun orbit more slowly. But here's what blew her mind. The outer stars were moving just as fast as the inner ones. The only way this was possible was if there was a massive amount of invisible matter providing the extra gravitational pull. Her discovery revealed that galaxies are like icebergs. What you see is just a tiny fraction of what's actually there. For every kilogram of normal matter in a galaxy, there are about 5 kilograms of dark matter. This means that 85% of the matter that makes up galaxies is completely invisible to us. But here's where it gets really wild. Computer simulations, run by scientists like Dr. Carlos Frank at Durham University, have shown us what the universe would look like if we could see dark matter. Instead of the relatively empty space between galaxies that we observe, we'd see a vast cosmic web. Imagine a three-dimensional spider web stretching across the entire universe, with dark matter filaments connecting massive dark matter halos, where galaxies eventually form. These simulations, called the Millennium Simulation, processed 10 billion dark matter particles over several months of computer time and revealed something absolutely stunning. The large-scale structure of the universe looks remarkably similar to the neural networks in your brain. The cosmic web of dark matter has the same branching, interconnected structure as the neurons firing in your head right now as you process this information. Think of it like this. Dark matter halos are like invisible parking lots scattered throughout the early universe. They provide the gravitational wells where normal matter can eventually collect and form stars and galaxies. Without these dark matter scaffolds, the universe would just be a thin, uniform soup of hydrogen and helium with no structure at all. But here's the truly mind-bending part. The dark matter halos that would eventually become our Milky Way galaxy formed when the universe was less than 1 billion years old. That means the invisible foundation of our cosmic home was already in place before the oldest stars we can observe had even been born. This leads us to a profound realization. Every galaxy birth story is actually a story about invisible architecture becoming visible. It's about dark matter providing the stage for the greatest show in the universe. The birth of stars and the formation of cosmic cities can finally begin. But this raises an unsettling question that we'll explore later. If our entire cosmic Existence depends on this invisible dark matter. What happens if we discover we've been wrong about how it behaves? Now, here's where the story gets absolutely incredible. You know those tiny temperature fluctuations in the cosmic microwave background? Radiation, the afterglow of the Big Bang that we can still detect today? Those seemingly insignificant variations, smaller than 1 part in 100,000, were actually the seeds that grew into every galaxy in the universe. Dr. Alan Guth from MIT figured this out when he developed the theory of cosmic inflation in 1981. He realized that quantum fluctuations during the first fraction of a second after the Big Bang got stretched to cosmic scales by rapid expansion. Think of it like this. Imagine drawing tiny random dots on a balloon and inflating that balloon to the size of a basketball. Those tiny dots become much larger patterns spread across the surface. But here's what will blow your mind. Those quantum fluctuations weren't random. They followed specific mathematical patterns that we can still observe today in the distribution of galaxies across the universe. The galaxy you're sitting in right now exists because of quantum uncertainty that occurred when the entire observable universe was smaller than a proton. Let me give you a mind-bending analogy. Think of the early universe as a perfectly still pond. The quantum fluctuations were like tiny ripples on that pond. But instead of dying out, these ripples got amplified by cosmic inflation until they became tsunami-sized waves of matter and energy. Where these waves were slightly denser, dark matter began to collect. Where they were slightly less dense, cosmic voids formed. The Wilkinson Microwave Anisotropy Probe, launched in 2001, gave us an incredibly detailed map of these primordial fluctuations. When scientists compared this map to the current distribution of galaxies, they found an almost perfect match. The hot spots in the cosmic microwave background corresponded exactly to regions where we see galaxy clusters today, while the cold spots matched the cosmic voids. Here's the truly staggering part. We can trace a direct line from quantum fluctuations that lasted for less than a trillionth of a trillionth of a trillionth of a second to the galaxy cluster you're currently part of. The local group of galaxies, which includes the Milky Way, Andromeda, and dozens of smaller galaxies, all formed from the same primordial seed. But the story gets even more incredible. Dr. Jim Peebles, who won the 2019 Nobel Prize in Physics for his work on theoretical cosmology, showed that these early fluctuations had to be incredibly precise. If they had been just slightly larger, matter would have collapsed into black holes too quickly for stars to form. If they had been slightly smaller, gravity would have been too weak to overcome the expansion of the universe, and no structures would have formed at all. Think of it like this. The universe had to thread an incredibly narrow needle for galaxies to exist. The margin for error was less than 1 part in 1015. That's like hitting a target the size of a coin from a distance of 26 million miles. Yet somehow, the universe hit that target perfectly, not once, but trillions upon trillions of times across cosmic space. This precision has led some scientists to propose the anthropic principle, the idea that the universe's physical constants seem fine-tuned for the existence of galaxies, stars, planets, and ultimately life. But other scientists, like Dr. Max Tegmark at MIT, argue that we might be living in just one of infinitely many universes, each with different physical constants, and we naturally find ourselves in one where galaxies can form. But here's the question that will keep you up at night. If the formation of galaxies depended on such incredible precision, what are the odds that we're living in a simulation where someone or something deliberately set these parameters to allow galaxies to exist? Picture this. For nearly 400 million years after the Big Bang, the universe was completely dark. Number: stars, no galaxies, no light of any kind. Just invisible dark matter halos, growing larger and larger, pulling in more and more hydrogen and helium gas. Scientists call this the dark age of the universe, but I prefer to think of it as the universe's pregnancy, a period of invisible growth before the cosmic birth of the first galaxies. Then something extraordinary happened that changed everything forever. The first stars began to shine, but here's what will blow your mind. These weren't ordinary stars like our sun. The very first generation of stars, called population 3 stars, were absolute monsters. While our sun has a mass of about 330,000 Earths, these primordial giants were 100 to 300 times more massive. They burned incredibly hot and bright, and they lived fast and died young, lasting only a few million years before exploding as the most powerful supernova the universe has ever seen. Dr. Richard Ellis from University College London has spent decades trying to detect these first stars with the Hubble Space Telescope and now the James Webb Space Telescope. He's found galaxies that formed when the universe was less than 600 million years old, incredibly young by cosmic standards. But here's the shocking part. Even these early galaxies are already mature, organized structures with billions of awe. Stars. Think of it like this. Imagine you're studying the history of cities, and you expect to find the first settlements as small villages. But instead, the oldest settlements you can find are already massive, complex cities with skyscrapers, subway systems, and millions of inhabitants. That's exactly what we're seeing with early galaxies. They seem to have grown up incredibly fast. This rapid growth was driven by something called feedback loops. When the first massive stars exploded as supernova, they didn't just create and scatter heavy elements like carbon, oxygen, and iron throughout space. They also created powerful shock waves that compressed nearby gas clouds, triggering the formation of even more stars. It was like a cosmic chain reaction. But the story gets even more incredible. Dr. Sandra Faber from UC Santa Cruz discovered that these early star formation episodes were so intense that they actually blew most of the gas out of small galaxies entirely. Think of it like this. Imagine a firecracker going off in a soap bubble. The explosion would pop the bubble and blow all the soap away. That's what happened to many small galaxies. They formed their first generation of stars. Those stars exploded, and the explosions were so powerful that they ejected all the remaining gas, preventing any future star formation. This is why we see so many fossil galaxies today, small collections of old, red stars with no young blue stars and no gas for future star formation. They're the cosmic equivalent of ghost towns, remnants of that violent early era when star formation was much more intense than it is today. Here's your next mind-blown moment. The reason you exist is because our galaxy was large enough to survive this early violence. The Milky Way's dark matter halo was massive enough to hold on to its gas, even when the first supernova went off. If we had formed in a smaller dark matter halo, all the gas would have been blown away, no sun would have formed, no Earth would have existed, and you wouldn't be here watching this video. But the most incredible part of this story is what happened to all those heavy elements created by the first generation of stars. When they exploded, they seeded the universe with the ingredients needed to form planets and life. The calcium in your bones, the iron in your blood, the oxygen you're breathing right now, all of it was forged in the nuclear furnaces of these primordial giants and scattered across space by their explosive deaths. Carl Sagan famously said, "We are made of star stuff, but it's more specific than that. We are made of the death throes of the first generation of stars that ended the cosmic dark age and began the era of galaxy formation." This raises a profound question. If the violent birth of the first galaxies was necessary to create the elements that make life possible, does this mean that destruction and creation are fundamentally linked in the universe? Here's something that will completely change how you think about galaxies. They're not peaceful island universes floating serenely through space. They're actually cosmic predators engaged in an endless feeding frenzy, constantly devouring smaller galaxies to fuel their growth. Right now, as you're watching this video, our Milky Way galaxy is in the process of cannibalizing at least 3 smaller galaxies. The Sagittarius dwarf elliptical galaxy is being stretched into a long stream of stars as our galaxy's gravity tears it apart. The Canis major dwarf galaxy is being shredded as we speak, and the large and small Magellanic clouds are slowly spiraling toward us, destined to be consumed within the next few billion years. Dr. Gary Gilmore from Cambridge University used the European Space Agency's Gaia satellite to map the positions and motions of over 1 billion stars in our galaxy. What he discovered was absolutely mind-blowing. The outer regions of the Milky Way are filled with streams and clumps of stars that don't belong to our galaxy's original structure. They're the remains of dozens of smaller galaxies that our galaxy has devoured over the past 10 billion years. Think of it like this. Imagine you could see the archaeological layers of a city that has been continuously inhabited for thousands of years. You'd find remains of the original settlement, plus layers from every civilization that came after, each built on top of the ruins of the previous one. That's exactly what the Milky Way looks like when we map its stellar populations. It's an archaeological record of galactic cannibalism, stretching back billions of years. But here's where it gets really wild. This galactic cannibalism isn't random or chaotic. It follows very specific rules based on what's called the merger tree of dark matter halos. Computer simulations by Dr. Volker Springel at the Max Planck Institute show that dark matter halos grow by merging with other halos in a hierarchical fashion. Small halos merge to form medium halos, which merge to form large halos, which merge to form galaxy clusters. Every time 2 dark matter halos merge, their embedded galaxies merge too. But galaxy mergers are incredibly complex events that can take billions of years to complete. When 2 galaxies of similar size collide, they don't just crash together and stick. They dance around each other in a gravitational ballet, exchanging streams of stars and gas, distorting each other's shapes, and triggering massive bursts of star formation as their gas clouds collide and compress. Here's your next mind-blown moment. The beautiful spiral structure of galaxies, like the Milky Way, is actually temporary. Every time a galaxy experiences a major merger, its spiral arms get destroyed and reformed. The spiral arms you see in those stunning Hubble images are like waves on the ocean. They appear stable, but they're actually dynamic patterns that constantly change over millions of years. The most dramatic example of this process is happening right in our cosmic backyard. The Andromeda Galaxy and the Milky Way are currently approaching each other at about 250,000 miles per hour. In approximately 4.5 billion years, they will collide in what astronomers poetically call galactopocalypse or Milkomeda. But here's what's absolutely incredible. Even though we call it a collision, it's more like 2 clouds of fireflies passing through each other. Galaxies are so mostly empty space that very few individual stars will actually collide. Instead, the gravitational forces will fling stars into new orbits, creating a completely new galaxy with a new structure. Dr. Roland van der Morel at the Space Telescope Science Institute has used Hubble observations to precisely measure Andromeda's motion and predict exactly how this merger will unfold. The simulation shows our solar system will likely be flung to the outer regions of the new merged galaxy, but Earth and the Sun will survive the encounter intact. Think of it like this. Galactic mergers are like cosmic recycling programs. Nothing is really destroyed. It's all just rearranged into new configurations. The stars from both galaxies will continue to shine, but they'll be part of a new, larger galactic structure. This process of galactic growth through merger and accretion has been happening throughout cosmic history. The largest galaxies we see today Giant elliptical galaxies in the centers of galaxy clusters are the result of countless mergers over billions of years. They're like cosmic cities that have absorbed all the surrounding towns and suburbs. But this raises a fascinating question. If galaxies grow by eating other galaxies, and if every galaxy will eventually be consumed by a larger galaxy, what does this mean for the ultimate fate of all structure in the universe? Now I'm going to tell you something that will completely revolutionize how you think about galaxy formation. At the center of every large galaxy, including our own, lurks a supermassive black hole with a mass millions to billions of times greater than our sun. And here's the truly mind-bending part. These cosmic monsters aren't just passengers along for the ride. They're actually the architects that control how their host galaxies grow and evolve. This discovery has forced astronomers to completely rewrite the story of galaxy birth. For decades, we thought galaxies formed first, and then black holes grew in their centers. But we now know it's the opposite. Supermassive black holes and their host galaxies grow together in a cosmic dance that has been choreographed by the laws of physics. Dr. Andrea Gies from UCLA spent over 2 decades tracking the motion of individual stars near the center of our galaxy using the world's most powerful telescopes. Her observations, which earned her the 2020 Nobel Prize in Physics, prove that there's a supermassive black hole called Sagittarius, an asterisk sitting right at the Milky Way's heart, with a mass 4 million times greater than our sun. But here's what will blow your mind. Despite being called a black hole, Sagittarius A** is actually one of the brightest objects in our galaxy when observed in certain wavelengths of light. As matter falls toward the black hole, it forms what's called an accretion disk, a swirling whirlpool of superheated gas that glows brighter than 1 trillion suns. Think of it like this. Imagine a cosmic blender that's so powerful it can process entire solar systems. As the black hole feeds, it doesn't just quietly swallow material. It creates jets of particles and energy that shoot out from its poles at nearly the speed of light, extending for hundreds of thousands of light years into space. These jets are incredibly powerful. They contain enough energy to heat all the gas in the entire galaxy. And here's where it gets really incredible. This heating process actually regulates star formation throughout the galaxy. When the central black hole is actively feeding, it heats up the surrounding gas so much that it can't collapse to form new stars. When the black hole runs out of food and goes quiet, the gas cools down and star formation resumes. Dr. Priyamvada Natarajan from Yale University has shown that this relationship between supermassive black holes and their host galaxies is so tight that there's a precise mathematical relationship between the mass of a galaxy's central black hole and the mass of its central stellar bulge. This relationship holds for every galaxy we've observed, from small dwarf galaxies to giant ellipticals. The implications of this discovery are absolutely staggering. It means that supermassive black holes act like cosmic thermostats, controlling the temperature and star formation rate of their entire galaxies. They're not just destructive forces, they're actually essential for galaxy formation and evolution. But here's the truly mind-bending part. We still don't fully understand how supermassive black holes got so massive so quickly. The first supermassive black holes formed when the universe was less than 1 billion years old, but conventional black hole growth mechanisms can't explain how they got so large so fast. It's like finding a fully grown oak tree in a forest that's only a few years old. This has led to some wild theories. Some scientists propose that the first supermassive black holes formed directly from the Yuckly collapse of massive gas clouds in the early universe. Others suggest they grew from seed black holes, created by the first generation of massive stars. Dr. Marta Volonteri from the Institute of Astrophysics in Paris has even proposed that some supermassive black holes might have formed from dark matter itself. Here's your next mind-blown moment. The Event Horizon Telescope, which captured the first image of a black hole in 2019, revealed something incredible about the supermassive black hole in the galaxy, M87, despite having a mass 6.5 billion times greater than our Sun. This black hole is rotating so fast that the space around it is literally being dragged along with it, creating a whirlpool in the fabric of space-time itself. Think of it like this. Imagine a bowling ball spinning so fast on a trampoline that it creates a spiral pattern in the trampoline's surface. That's what's happening around supermassive black holes. They're actually twisting the geometry of space and time around them. This phenomenon, called frame dragging, means that nothing near a supermassive black hole can remain stationary relative to the distant universe. Everything gets caught up in the black hole's spin, creating a region called the ergosphere, where the very concept of being at rest ceases to exist. But perhaps the most incredible discovery about supermassive black holes is that they might actually be responsible for creating the conditions necessary for life. The jets and outflows from active supermassive black holes distribute heavy elements throughout galaxies and trigger star formation in distant regions. Without this cosmic recycling process, the elements needed for planets and life might never have spread throughout the universe. This raises a profound question. If supermassive black holes are essential for galaxy formation and possibly for life itself, does this mean that the most destructive objects in the universe are also the most creative? Here's something that will completely transform your understanding of the universe's architecture. Galaxies aren't randomly scattered through space like stars in the night sky. They're actually connected by invisible highways made of dark matter and gas, forming what astronomers call the cosmic web, the largest structure in the universe. Imagine you could step back and see the entire observable universe from the outside. Instead of seeing isolated galaxies floating in empty space, you'd see something that looks remarkably like a vast three-dimensional spider web stretching across billions of light years. Galaxies sit at the intersections of this web like dewdrops on spider silk, connected by filaments of dark matter that channel fresh gas and smaller galaxies toward the growing galactic cities. Dr. Margaret Geller from the Harvard-Smithsonian Center for Astrophysics made this discovery in the 1980s, when she began mapping the positions of thousands of galaxies in 3 dimensions. What she found was absolutely revolutionary. Galaxies are arranged in enormous sheets and filaments surrounding vast empty regions called cosmic voids. The largest structure she discovered, called the Great Wall, is a sheet of galaxies that stretches for over 500 million light years across the sky. To put that in perspective, if you could travel at the speed of light, it would take you half a billion years to cross from one end to the other. But here's what will blow your mind. This cosmic web isn't static. It's actually flowing like a vast network of cosmic rivers. Gas flows along the dark matter filaments toward the galaxy clusters, feeding the growth of galaxies at the nodes. Think of it like a transportation system where dark matter filaments are the highways, gas is the cargo, and galaxies are the cities where the cargo gets delivered. Dr. Anatoly Klipin from New Mexico State University has run massive computer simulations that track billions of dark matter particles over the entire age of the universe. These simulations reveal that the cosmic web has been growing and evolving for 13.8 billion years, with small filaments merging into larger ones, and small nodes growing into massive galaxy clusters. Here's the truly incredible part. When astronomers compare these computer simulations to actual observations of galaxy positions, they match almost perfectly. This means we can actually predict where galaxies should be located based on the underlying dark matter structure, even though we can't see the dark matter directly. But the story gets even more amazing. Dr. Brent Tully from the University of Hawaii discovered that our local group of galaxies, including the Milky Way and Andromeda, is part of an enormous structure called the Laniakea supercluster. This cosmic metropolis contains over 100,000 galaxies spread across 520 million light years, all connected by the gravitational influence of the cosmic web. Think of it like this. Just as your hometown is part of a county, which is part of a state, which is part of a country, our galaxy is part of the local group, which is part of the Virgo cluster, which is part of the Laniakea supercluster, which is part of even larger structures that we're still discovering. The name Laniakea comes from Hawaiian words meaning immense heaven, and it's an incredibly fitting name. This supercluster is so large that even if you could travel at the speed of light, it would take you over 500 million years to cross from one side to the other. But here's where it gets really mind-bending. All of the galaxies in Laniakea are flowing toward a mysterious region called the Great Attractor. This gravitational anomaly, hidden behind the plane of our galaxy, has a mass equivalent to tens of thousands of Milky Ways and is pulling our entire local region of the universe toward it at about 600 kilometers per second. Recent observations with radio telescopes that can peer through the dust of our galaxy have revealed that the Great Attractor is actually part of an even larger structure called the Shapley supercluster, which contains thousands of galaxies and has a total mass of about YP solar masses. To put that in perspective, that's about 10 million times more massive than our entire galaxy. Here's your next mind-blown moment. This cosmic web structure that connects all galaxies was actually predicted by theoretical physicists before it was discovered observationally. In the 1970s, Soviet physicist Yakov Zeldovich calculated that if dark matter clumps under its own gravity, it would naturally form a web-like structure with dense nodes, connected by filaments and separated by empty voids. When astronomers finally had the technology to map galaxy positions in 3 dimensions, they found exactly the structure that Zeldovich had predicted. It was like finding that nature had built a cosmic construction project according to a blueprint written decades earlier by theoretical physicists. Think of it like this. The cosmic web is like the circulatory system of the universe, with dark matter filaments as the arteries and veins, gas as the blood, and galaxies as the organs where cosmic metabolism takes place. Every galaxy, including our own, is connected to every other galaxy through this vast network. But this raises a profound question. If all galaxies are connected through the cosmic web, and if matter is constantly flowing along these connections, does this mean that the universe is actually a single, vast, living organism? Here's something that will completely blow your mind. Every atom in your body has been recycled through multiple generations of stars and galaxies over billions of years. You are literally made from the ashes of cosmic recycling programs that have been running since the first galaxies formed. When the first galaxies began to form about 13 billion years ago, the universe contained only hydrogen, helium, and tiny traces of lithium. There was no carbon, no oxygen, no silicon, no iron, none of the elements that make planets and life possible. But here's the incredible part. Galaxies didn't just form stars. They became cosmic factories that manufactured and distributed every element heavier than lithium. Dr. Christina Tremonti from the University of Wisconsin has spent years studying how the chemical composition of galaxies changes over time. Her observations with the Sloan Digital Sky Survey revealed something absolutely incredible. We can actually see galaxies in the process of enriching themselves with heavy elements by observing galaxies at different distances, and therefore different times in cosmic history. Think of it like this. When you look at distant galaxies, you're seeing them as they were billions of years ago, because their light has taken that long to reach us. Close galaxies show us the present, while distant galaxies show us the past. By comparing the chemical compositions of galaxies at different distances, we can actually watch the chemical evolution of the universe unfold over cosmic time. Here's what this reveals. The earliest galaxies contained almost no elements heavier than helium. As we look at galaxies formed later and later in cosmic history, we see them becoming progressively more enriched with heavy elements. It's like watching the universe learn chemistry, one stellar generation at a time. But the story of how these elements get distributed throughout galaxies is absolutely incredible. When massive stars explode as supernova, they don't just create heavy elements. They blast them out into space at speeds of up to 30,000 kilometers per second. These supersonic shock waves sweep up surrounding gas and create enormous bubbles of hot, element-rich material that can expand for millions of years. Dr. Sally Owie from the University of Michigan has used the Hubble Space Telescope to study these supernova bubbles in nearby galaxies. What she found was mind-blowing. A single supernova explosion can create a cavity in the galaxy's gas that's over 1,000 light years across, larger than the distance from Earth to the nearest star, multiplied by 1,000. These bubbles don't just sit there. They merge with other bubbles created by nearby supernova, forming a network of hot, low-density channels that astronomers call the galactic fountain. Hot gas rises through these channels, carrying heavy elements high above the galaxy's disk, where it cools and eventually falls back down like cosmic rain, distributing the newly created elements throughout the galaxy. But here's the truly incredible part. This galactic recycling process isn't confined to individual galaxies. Dr. Crystal Martin from UC Santa Barbara has discovered that many galaxies are surrounded by enormous halos of hot gas that extend far beyond the visible stellar disk. This circumgalactic medium acts like a cosmic atmosphere, storing gas that has been ejected by stellar winds and supernova, and will eventually fall back to fuel future star formation. Think of it like this: galaxies breathe. They inhale fresh hydrogen gas from the cosmic web, process it into stars, and exhale enriched gas back into their surroundings. This breathing process has been going on for over 13 billion years, gradually increasing the heavy element content of the universe. Here's your next mind-blown moment. The oxygen you're breathing right now was created inside massive stars that exploded as supernova billions of years ago. The calcium in your bones was forged in stellar cores and distributed by stellar winds. The iron in your blood was created in the final moments before a massive star collapsed into a neutron star or black hole. But it gets even more incredible. Dr. Anna Frebel from MIT studies the most metal-poor stars in our galaxy, ancient stars that formed from gas that had been enriched by only one or two previous generations of stars. These stellar fossils tell us exactly which elements were created by the very first supernova in the universe. What she discovered is that different types of stellar explosions create different patterns of elements. Core collapse supernova from massive stars create lots of oxygen, neon, and magnesium. But iron-peak elements like iron, nickel, and cobalt are primarily created in thermonuclear supernova, the explosive deaths of white dwarf stars and binary systems. This means that the chemical composition of your body tells a story about cosmic history. The elements were created in different types of stars, at different times, in different parts of the galaxy, and through different processes. You are literally a walking museum of galactic chemical evolution. Think of it like this. If you could trace the journey of every atom in your body backwards through time, you'd find that they've been on incredible cosmic adventures. Some spent billions of years drifting through interstellar space. Others were part of previous generations of stars that lived and died before our sun was even born. Some might have been ejected from our galaxy entirely and then fell back in along cosmic web filaments. The galactic recycling process is so efficient that astronomers estimate the average atom in your body has been through at least 2 or 3 complete cycles of stellar birth, death, and rebirth. You're not just made of star stuff. You're made of recycled star stuff that has been processed multiple times through the cosmic recycling program. But here's what will really blow your mind. This recycling process is still happening. Right now, as you're watching this video, massive stars throughout the galaxy are creating new heavy elements and preparing to distribute them through future supernova explosions. A galaxy is constantly replenishing its supply of the elements that make planets and life possible. This raises a profound question. If life depends on the chemical enrichment of galaxies through stellar death and recycling, does this mean that life and death are fundamentally connected, not just on Earth, but throughout the entire universe? Now I want you to pause for a moment and think about where you are right now. You probably think of your location as a city, state, or country on Earth, but your real cosmic address is far more incredible than you've ever imagined. And understanding it will completely transform how you see your place in the universe. Let's start with your full cosmic address. You live on Earth, the third planet orbiting a middle-aged yellow dwarf star called the Sun, located about 26,000 light-years from the center of the Milky Way galaxy, in a spiral arm called the local arm or Orion spur, which is itself part of the local group of galaxies embedded in the Laniakea supercluster, connected to billions of other superclusters through the cosmic web that spans the entire observable universe. But here's what will blow your mind. Every part of this cosmic address is in motion. You're not sitting still watching this video. You're on a planet that's rotating at 1,000 miles per hour at the equator, orbiting a star at 67,000 miles per hour, in a solar system that's moving through the galaxy at 514,000 miles per hour, in a galaxy that's moving through the local group at 1.3 million miles per hour, in a local group that's falling toward the Virgo cluster at 1.4 million miles per hour. Dot all those motions together, and you're actually traveling through the cosmic web at about 2.1 million miles per hour, relative to the cosmic microwave background radiation. That means in the time it took you to read this paragraph, you've moved about 1,000 miles through the universe. Think of it like this. You're not watching this video from a fixed location. You're watching it from a spaceship called Earth that's hurtling through the cosmos at incredible speed, following a complex orbital dance that's been choreographed by the gravitational forces of galaxy formation over billions of years. But your connection to galaxy formation goes much deeper than thin. Just your location. Remember those dark matter halos we talked about earlier? You're living inside one right now. The Milky Way's dark matter halo extends at least 300,000 light years from the galactic center, about 3 times farther than the visible edge of our galaxy. This invisible scaffold that enabled our galaxy to form is surrounding you right now, holding our cosmic home together with its gravity. Here's something that will give you chills. The dark matter particles that helped form our galaxy are passing through your body right now. Every second, trillions of dark matter particles are streaming through you completely undetected. You are literally immersed in the same invisible substance that made galaxy formation possible. Dr. Catherine Fries from the University of Michigan calculates that about 70,000 dark matter particles pass through your body every second. They don't interact with your atoms. They just pass straight through as if you weren't even there. But their collective gravitational effect holds our entire galaxy together and determines the orbit of our solar system around the galactic center. But here's the most incredible part. The very existence of your consciousness might be connected to the specific way our galaxy formed. The Milky Way's formation history, the particular sequence of mergers, the timing of star formation episodes, the chemical enrichment process. All of these factors had to occur in exactly the right way, and at exactly the right times to create the conditions that led to your existence. Think about it. If our galaxy had formed differently, if it had experienced a major merger 4 billion years ago, if the supermassive black hole at its center had been more active. If the rate of chemical enrichment had been slower, the Sun might never have formed in a region with enough heavy elements to create rocky planets. Without rocky planets, there would be no Earth. Without Earth, there would be no life. Without life, there would be no consciousness to contemplate. Galaxy formation. This is what astronomers call the galactic habitable zone, the idea that life can only exist in certain regions of certain types of galaxies at certain times in their evolutionary history. You're not just living in a galaxy, you're living in exactly the right kind of galaxy, in exactly the right location, at exactly the right time for conscious life to exist. Dr. Charles Lineweaver from the Australian National University has calculated that about 10% of all stars in the Milky Way are located in the galactic habitable zone, close enough to the center to have sufficient heavy elements for planet formation, but far enough out to avoid the dangerous radiation environment near the supermassive black hole. But here's what will really blow your mind. You're part of the galaxy's ongoing evolution. The carbon dioxide you exhale becomes part of the interstellar medium. When you die, the atoms in your body will eventually be recycled into future generations of stars and planets. You're not separate from the galaxy. You're an active participant in its chemical evolution. Every breath you take connects you to the cosmic recycling process that has been running for 13 billion years. You're not just made of recycled star stuff. You're actively contributing to the galaxy's chemical inventory. Every moment you're alive. This raises a profound question. If your existence is intimately connected to the specific formation history of our galaxy, and if you're actively participating in its ongoing evolution, does this mean that consciousness itself is a fundamental part of how galaxies develop and change over time?